is on page 22. Okay, so we talked about the three main polynomials here. So we've got linear. It has a degree of 1. And in general, it looks like this. And this is called the leading coefficient. And it tells us two things. Direction. I'm going to modify this a little bit. The direction. So if A is positive, we expect our line to go up from left to right. And let's talk about end behavior. Do you remember end behavior? We're talking about where the ends of this graph are going to end up. So a positive will go from quadrant, which one is this one here? 3, 2, 1. 3, 2, 1. Right? It ends up, like if this is your Cartesian plane, no matter what, one end is in 3, the other one is in 1, no matter what. Because it goes like this, Jen. 1, 2, 3, 4, right? Okay. If A is negative, we expect the line to go down. So then we're going to go from quadrant 2 to quadrant 4. That's your end behavior. I don't know if you need to write down what those numbers represent, write down end behavior. I would say this is a great study sheet entry if you can somehow compress it. And then this part right here, the constant, constant, that would be the y-intercept, right? And it also gives me, if you were to change it, if you were to change that value, it produces a vertical shift. It would bring the line either up or down. By the way, that's the truth. That's true about all of the polynomials. If you change the back number, you're bringing up or down. 22. So I just have a little, just a little exploration here for you to see. It's a little glary, right? But A being positive, if it's 1, it's going to point up, and it actually also determines how steep your line is going to be. If it's negative, we go right from left to right, it's going to be going down every single time, no exceptions. B, which is the constant at the end, look what happens if I change it. If I decrease it, it goes down. If I increase it, everything goes up, okay? However, what is B right now? It's 8.5 according to this, right? So if you tap on this, that is also, right now, if we leave it like that, it's the coordinates of our y-intercept. Okay, so these are basic tools. Where are we going with this, guys? Word problems. You know we're going to word problems, right? So when we have a word problem, we may not care about everything else. We want to just maybe stay within the first quadrant here. So let's say you want to know how much gas is in your tank if you drive to a different city. You would start with a full tank, and then it would slowly go down, right, as you get to your destination, right? So that's kind of like the idea, a little bit of a context around this. Let's add, my pencil is almost dead, so I'm going to keep charging in here. So that's that. Oh yeah, domain and range. That's what I wanted to add next to this. Your domain is all real numbers, or negative infinity to positive infinity. Your range, in this case, is also all real numbers, or negative infinity to positive infinity. Okay? Because it just never ends. In general, once we do word problem, this is just general, okay? If there's a word problem attached to it, please don't write that down without thinking about what's happening, okay? Okay, let's cut this. I'm going to cut this here. I think we're good. You know what? I'm going to, direction of opening, and I will also say steepness. Right? That is not super important, but I think it's worth mentioning. Like if it's very steep, the bigger A is, the steeper this line is going to be. Okay. Next is our quadratic. It has a degree of 2. It will result in a parabola. And this is very important. That's why we are able to predict points, because a parabola is symmetric. Yeah.
Will you be forced to use one format of domain and range?
No, not if you have to state it, not. But if they give you a multiple choice question, they might give you a linear. It's like, which one of these is the proper domain and range? So you got to be able to read it. Okay, so quadratic in general looks like this. Can I just say, I hope you know this, but if in a quadratic, if the x term isn't there or the c isn't there, it's 0. Okay, b is 0 if x is missing. If c is missing, it's 0. So just don't say that it's not there. It's just 0. So again, this is called the leading coefficient, and it tells us the direction of opening. So if A is positive, we're expecting this. If A is negative, we expect this. This here is the y-intercept, and also it determines the vertical shift. I will do this here. If the parabola, if it goes up like this, let's give this, let's give the vertex a point here. So this would be 2, -3, let's say. That's the vertex. My domain here would be x belongs to all real numbers, because it never ends. In terms of your x values, it never ends. I'm pretty sure, you got to refresh my memory. Friday, did I make you watch a domain and range video? I think so. If you didn't, go review it if domain and range is far away, somewhere in your memory, distant memory. So it'd be either one, or for the range, here you have to be careful. The range is the y value. The lowest is -3. So in this case, you would have to say y is greater than or equal to -3. Or you would go from 3, -3, all the way to positive infinity. Let's do that exact same scenario, but it pointing down. I will keep the vertex the same. Domain, I'm still going to keep it the same. the range, in this case, it's pointing down, right? So the y values, the only y values that we accept would be -3 or less. So you'd go negative, y is less than or equal to -3. Or, if you want interval notation, it goes from -infinity all the way to -3. So in other words, should the range of a parabola ever be -infinity to +infinity? For a parabola, for a quadratic? Should the range ever be -infinity to +infinity? Never. It will always be restricted on one end, either at the top or at the bottom. It depends on which way it's pointing. So maybe that's one thing that I want you to observe. If I give you choices, obviously, if I say, don't write this down, but if I say which one of the following graphs would have a range that is like that, and I give you a linear and a quadratic, those are your only choices, please don't pick quadratic, right, for this one. This would be a linear. Linear, yes, because it keeps going either way, but not a quadratic, okay? So just keep that in mind. Sometimes what not to pick is more beneficial to know that than what to pick. Okay, next, the last one is cubic. Oops. Cubic is a degree of 3. It looks like this. It could look like this. Sometimes it kind of has like a weird S shape along the way. Sometimes it looks like this. Oh, this one has S shape too. Why would I redo the same thing, right? Sometimes it doesn't have a turning point. It just has a bend. Okay, so keep that in mind. Let's keep going here. In general, it looks like this. Guess what? We're obsessed with the leading coefficient. Okay, guys? In this course we are. That tells us a lot. It tells us the behavior that we're expecting. So this is the leading coefficient. It behaves exactly the same as a linear, right? Because it has an odd degree. So if A is positive, then we're expecting something like this. Or it could also have like a weird bend. It doesn't matter. The ends go from 3 to 1. From 3 to 1. Okay, it doesn't matter. If A is negative, it's going to go the opposite way, right? It's going to go like this. It's going to go from 2 to 4. This is still your constant. That would be the y-intercept. And it would be a vertical shift. And here's something new, okay? I need you to know this so that you can kind of predict how weird is this thing going to be. Like, is it going to have that weird S shape in between? And I'm going to use a different color. Sorry, just the C and the X and the X squared, okay? My bad. I thought I wasn't going to have to use whiteout anymore, but I guess. Okay, so if these are present, will result in true turns. So if these are present, you will end up having the S shape in between. This one is asymmetric. It's asymmetric, okay? Meaning you can't really predict what's going to happen on the other side of the curve. So let me tell you what I mean by, like if you look at parabola, guys, a point on this leg is the same distance to the center as a point right across from it on this side of the curve, right? So they'll be the same distance apart. That is because of symmetry. A cubic may seem symmetric sometimes, but it isn't. So, like, what I mean by that is this point, if you find the highest, is not necessarily going to be again at the same distance to the center. You cannot make that assumption on a cubic function, which isn't really going to be a big problem anyways, but just so you know. Here's a cubic in action. A cubic in action, okay? Here we go. Okay, so A still tells us if it's negative, we expect it to go, sorry, A negative, we're expecting it to go down from left to right. If it's positive, it's going to go up from left to right. No surprises there. What happens to D? D is the constant. It causes a vertical shift, either up or down. If you make D 100, this thing would be all the way at 100, go through 100 somewhere. Okay, we know that. So it's the coordinates of the y-intercept, but if we change it, it will result in the whole thing going up or down. How many turns does this have, you think? You think 2? I hate to tell you, this one has 0 turns. It just has like a bend. It has a bend. And do you see that B and C are 0 right now? You see that? So technically they're non-existent here, it's 0. But let's see what happens as soon as I change it. I'll just play it. Oops. Okay. Some strange, it's almost like those signs, right? Yeah, the dealership signs, right? Or furniture. Okay. Oh. Pause. And then C will do the same thing. Probably like a dance move, right? Yes! Something like that. Okay. You can probably model a yes move right this. Anyways, ouch. I hurt myself during a cubic function. Yeah, what's that? Play them at the same time? I'm supposed to play them at the same time. Dun, 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 dun. It's almost like a screensaver. Okay? So B and C cause the bends. Okay? The turns, I should say, the turns. So if B and C are present, I can guarantee you that this thing is gonna have 2 turns. It's either 0 turns or 2 turns. Okay? What does D do again? If I change D, what happens to the curve? It goes up and down. The whole thing, it stays the same shape, but it goes up or down, up and down. Okay. Okay. I know you're too excited for this, so I need to move on. Otherwise, I'm going to lose you guys. Okay. All right. I think this is all I have. Oh, domain and range. What is going to be the domain and range for this one? There's no restriction, right? So if it doesn't matter what it looks like, whether it's like this or whether it's like this, the domain is all real numbers, and the range is also all real numbers. which translates to negative infinity to positive infinity, negative infinity to positive infinity. Okay? That's what it translates to. Okay.